Welcome, people, for the last session of this Geek Night. In this, let me present my screen. You people are able to see my screen?
Yes.
Yeah, Rami.
Yeah, thank you. Welcome back to the last session of this Geek Night session. Hope you are enjoying the content and finding it useful so far. My name is Rami. I'm working as a developer at ThoughtWorks, and I am the last spoiled kid joining this party of this Geek Night squad. Uh, in this session, we are going to primarily discuss about a few important aspects related to, the performance, availability, and also few interesting tools and what's happening new. So let's quickly jump onto the agenda. As I told you, in this session, we are going to primarily focus on two important aspects. The first aspect is going to be the KUDU, developer productivity tool, which is used by Azure App Service to manage and maintain the app service itself more effectively and efficiently. And then in the later part of the session, we are going to focus more on the best practices related to the availability and performance. Finally, we are going to conclude the session by learning the new things which are happening in Azure App Service and Azure App Service team, which is working on. Without any further delay, let's jump on to the first topic, KUDU. So what is this KUDU? KUDU is a developer productivity tool. It's developed by Microsoft Azure team, and they have open sourced it. What is this tool? What does it does? And where does it actually stay? Where does it reside? Where does it hosted, right? Uh, it comes as a separate process running in the context of app service itself. The main purpose of this tool is to facilitate these continuous deployments. So when I say continuous deployment, let's say your code is residing in any of the repositories like GitHub, GitLab, and you want to have a continuous deployment. Whenever you commit a change, the code needs to be deployed to the app service. This is the tool which is responsible for that. Apart from this continuous deployment, it also exposes few HTTP endpoints through which you can do your own custom deployments. Like, you have built the zip package in your local, and then you wanted to do the deployment onto Azure App Service. This is the tool which you have to look out for. Uh, now, let's step back and understand, why do we need a separate tool to do the deployments? We already have these tools, right? Like FTP deployment, web deploy, and similar tools related of that nature, right? Well, the answer is simple. It's not just a tool which actually facilitates the deployments, but also it provides additional perks, additional features and functionalities through which you can manage and maintain your app service more efficiently. Let's see a few of the tools, right? It provides a debug console through which you can run few of your administrative tasks, and also we can run few commands. And also it provides developer tools through which we can do certain operations related, like managing the webhooks or debugging the diagnostic dumps, and also monitoring the web jobs, just like how Rahul was mentioning about the different web jobs which can be hosted in the app service. We can monitor them using these developer tools. It also provides a process explorer, which actually displays the current state of all the processes which are running in the app service, and thereby we can monitor them more efficiently. Finally, it also provides us a feature called extensions, through which we can extend the default functionalities of the Azure App Service with new ones. Let's quickly see a few of these features in action. I'm in the Azure portal. I have logged into the same app service which is being discussed so far in this Geek Night. And to navigate to this KUDU, which we call it as a KUDU dashboard, all I have to search for advanced tools. And when I click on this advanced tools, it will be taking me to the KUDU dashboard. In the interest of time, I've already opened that KUDU dashboard for us. This is the KUDU dashboard. It basically describes certain metadata information related to the app service, and also it provides few options, navigation options on the top, through which we can navigate between different features and functionalities. At the same time, it also exposes few REST API endpoints. The same data which is being used by these features is also exposed as REST API. We can monitor the data and we can develop our own custom tools on top of that. Let's quickly navigate between these different features and understand what they are capable of doing. The first one is environment. This view presents the current state of the configuration of all the different aspects of the app service. It starts with the system information, where we have information related to the operating system, process, CLR versions, and also interestingly, it shows the memory and the disk space which is being used by the app service. And followed up, we have app settings and connection strings, which shows us the current application settings, just like how Surbi was describing about the configuration. Uh, it describes the current app settings and connection strings which are being used by the app service, followed by all the different environment variables. Similarly, we have path variables, HTTP headers, server variables. Now, this view gives us the holistic experience, right? I mean, we can understand, we can retrospect, we can reconcile this configuration and make necessary changes to our app service to make it more efficient. Moving on, we have a capability to have a debug console, which comes in two flavors, command line prompt, a typical Windows command line prompt, and we do also have a PowerShell. If it is a Linux-based app, obviously we'll be having a shell command over here. And this, using this diagnostic console, let me quickly show that diagnostic console. This diagnostic console has two parts. The first one is a file explorer kind of a view, where it actually showcases the folder structure of the app service itself. We can go into within each and every folder, and also at the same time, let it get open. In the meantime, while it get loaded up, the console at the bottom is pretty much useful to run few commands. We can create directories, we can delete directories, we can move files, we can copy files, and we can do a whole lot of activities, just like in our Windows command line prompt. I think it's taking a while to load this. Yeah, it got loaded up. Now, one of the feature this view where we have this file explorer gives us was we can download the content, we can delete the folders, and at the same time, if there are individual files, we can edit the files as well here itself. Let's quickly see if I can edit few files. Let me refresh the view. Let's come back to this diagnostic console and editing this file. Let's move on to the process explorer, which is the next feature which I wanted to talk about. Process explorer showcases the current state of all the processes which are running within the context of the app service. Now we can see there are two major processes, right? Uh, Now we have one app service. Why do we need two processes? And they both are worker process. Uh, to give you the context, one process is primarily is responsible for running the app within the app service itself. I mean, this process 25124 is the process which is running our code. It is the process which is hosting our web app. Now, the other process where we have SCM, which is source control management tool, this provides a, hosting body for different subsidiary processes. Like I want to collect some diagnostic traces. I want to collect application insights information. I want to run through some logs. All these different processes will be running under this worker process, which is a subsidiary process. But the actual traffic is being served through the main W3WP worker process. Now, this view also presents a good amount of information where we can find CPU, how much CPU is being used, how much CPU time is being used, and also what is the current working set and private set memory. And also I can get into the details of the properties of this particular process alongside, let me close this. The interesting part of this view was start profiling. So when I click on the start profiling, Azure captures the diagnostic trace of this particular process, which is running under this worker process. And when I do stop profiling, it will download me the entire diagnostic trace, which is being captured, and uh, I can do further exploration of that particular diagnostic trace, and I can learn more about this worker process, like what are the things going wrong, how can I optimize it further, uh, which part of the code is taking more CPU, which is consuming more memory. I can take my own decisions by tracing out that information. Let's quickly get back. Yeah, now this being opened up. Let me see if I can actually go back into the site. Let it load. In the meantime, let's go onto the site extensions. This is my favorite topic. Site extensions is something. Let's define an extension, right? I mean, extension is an independent and an individual module which can be loaded onto a app service, which extends the default behavior of an app service. Uh, Okay, so far we have seen Rahul, Surbi, and Gaurav there showcased a lot of different features of app service, right? Why do we need new features? Like, because every application is different. Every application is different, and every application needs its own capabilities to maintain and troubleshoot for itself, right? So let's say my application wants to integrate with a APM tool like New Relic, or if I want to integrate with a logging provider like Elma, right? I have these custom requirements. Now I feel that these are the most common requirements. Probably others might also be facing, or others might be also be interested in, right? So what I can do was I can quickly create an extension, upload it into the app service, and thereby all the other people can simply go and search the extensions in this particular gallery and start adding those extensions to app service. Thereby, we can get that additional functionality into the app service itself. We do have a lot of different available extensions so far. We can use any of these, and we can also create our own. I think this site is getting loaded up. Yeah, now we have the individual files where we can quickly go and edit. Thanks to the demo gods, finally they are helping me out. That concludes the KUDU, the developer productivity tool, and how it is useful behind the scenes. Let's move on to the second part of the session, where we are going to primarily focus on the best practices related to the availability and performance. The first one, the first practice which we recommend uh, is to turn on the always on. What does this always on does? Always on prevents the app from being idled out due to inactivity. Now, why it is important? Azure as a platform was built in such a way that whenever it identifies a particular web app is not serving any traffic or it is sitting idle, it deprioritizes that. It unloads that and it keeps it in the cold state. Now, whenever the web app, the same web app started experiencing new traffic, I mean, the latest traffic, then Azure again loads that particular web app into the context. Now, during this time, our web app might be performing a little bad. It might be, we might be experiencing few slowness or sluggishness. And to prevent that, it is always advisable to turn always on feature. Moving on, it is also recommended to scale the app service to have at least minimum 3 instances. But the question comes, why 3 instances, right? Whenever we scale an app service to 3 instances, Azure will make sure that these 3 instances are connected to 3 different physical and logical domains, typically networks. How does that help? Uh, if a particular instance is actually tied up to a different instance, say for example, in case of transient failures or network issues or some platform upgrades or any maintenance activity which is being performed by Azure, not all my instances will be getting affected because they are actually tied up to different physical and logical tiers. Only few are impacted, and still my app can continue serve the audience. That is the reason it is always recommended to distribute the app to have at least 3 instances. Moving on, ARR affinity. ARR affinity in our traditional software terminology, it is called as stickiness, server stickiness. It is primarily used for scalable, stateful applications. Now, say, for example, there is a requirement from my side that I always need to connect to the same server, and all my requests are needs to be served from the same server because that server holds the information of me, or probably it is holding a session related to myself, right? In that case, it's advisable to turn ARR affinity on, but as per the modern industry standard practices, where we are going in the REST API model and typically following up the stateless architecture, it is always advisable to turn this ARR affinity cookie off so that we can get even distribution of traffic among all the instances of Azure, and thereby we can have efficient usage of Azure resources, be it with CPU, memory, or anything. So it is always advised to turn this one off. Fourth one, which I wanted to talk about, was having a minimum startup time. Now, how does this impact? This is not a Azure feature. This is our application code feature, right? This is what our application code does, right? Uh, Even though it is not related to Azure, I still wanted to talk about this one because it plays a crucial role when it comes to scaling. Now, assume you have only one instance and you're serving the traffic. All of a sudden, there was a big break in the traffic. I mean, breakthrough in the traffic. You started experiencing twofold, threefold of the traffic spikes. During that time, obviously, we want to scale the app service into multiple instances. Now, what if we scale an app instance and it itself take 5 minutes or 10 minutes to start loading up? During that time, my still traffic spike is ongoing. I'll not be able to serve the traffic, right? So it is always advisable to have a minimum startup time so that in case of traffic burst, we can immediately scale, dynamically scale, and start serving the traffic right away immediately. The last feature which I wanted to talk about, or the recommendation which I can talk about, was having minimum number of apps in the app service plan. As Surbhi was talking about app service and app service plan, we have an app service plan and we can put a app service into an app service plan, right? And we can put number of app services into app service plans. But the problem is, what is the limit? If we keep on putting a lot of different apps onto the app service plan, the resources of app service plan get exhausted, and thereby we will see a lot of performance issues across different apps. So it is always advisable to quantify how many apps can go on to a particular app service. And this is again different from situation to situation, app to app. It is always advisable to uh, do a performance load test on your app, identify how much metrics it will take when it's hosted on Azure, and thereby make a cautious decision of how many apps to be hosted in a app service plan. Typically, it is recommended to go in around 8 apps. Going anything above 8 apps within an app service plan needs a very cautious decision to be made. Let's quickly see a couple of features of this important recommendations, whatever we spoke about. I'm again in the same context of the app service. If I can quickly go to the configuration section where I have let the configuration to be loaded up. And in the general settings, if I can go down, I have always on feature, which is turned on by default. That's good. It's a good sign. ARR affinity, it is also turned on. Now mine is a stateless application. I want to turn it off. That improves the performance, and click on save. And talking about scaling, Rahul clearly showed us how we can actually scale up or scale out different app services at an app service plan level. Moving on, uh, okay, how would we end this session, right? I mean, how could we end this session in a best possible way? Only probably by discussing about the new features which are coming onto the app service. Uh, these are the 4 new things which I can talk about, which Azure team is currently working upon, even though they are available to us in preview, but they are pretty much being worked upon by the Azure team. I can quickly talk about few of the features. App service environments, again, these are different from the app service plans, and you have very specific requirement where you have memory intense, CPU intense, and really need a high scaled system, and it needs to be completely isolated and to be very secure. Then app service environments is something which you need to look at for. This is something in preview, and do expect few changes going forward in the app service environments because this is being continuously being iterated and developed. And the second feature was app service editor. This is something very similar to GitHub code spaces, where imagine I put VS Code in the browser and I start opening up my folder view of the app service which was getting hosted there. I can connect to the GitHub. I can connect to the source repository. And I can start playing around with the code in the browser itself, uh, in the editor which was loaded up in the browser, right? That is the feature which is called as app service editor. Again, this is in preview. Diagnostic settings, Azure provides by default a lot of different metrics and diagnostic traces and application logs by default. There are 2 parts to it, right? I mean, it provides the logs. Now we can download the logs and we can analyze it, or else let Azure analyze that one for us. Now that is something which can be dealt with diagnostic settings, where we can stream these logs to analytics, storage accounts, and event hubs, and we can efficiently monitor and analyze the logs very effectively. The last one we talked about was the deployment center. Thanks to Subi, she covered a lot of different options and opportunities what we have related to different deployment models which app service do support. And this deployment center is going to be a one-stop shop for all the related deployment activities. This is in preview and it is going to be live soon. Having said that, that concludes the session and also Geek Night.
So in the meantime, if somebody asks the question, so can we talk about the scaling, pricing, and all those things? So there was a question around the scaling up and scaling down and the costings.
Yes, Gaurav, else we can talk about it. So, do you want to show that?
Yeah, yeah, we can show that as well.
Yeah. Go ahead, yeah.
Okay. So quickly talking about the app service scaling plans and all those things. So as Rahul suggested already, we have two options: scale up and scale out. So once we do a vertical scaling, there is a pricing given already on the pricing tier that you will be choosing. So this loading option shows once the price will be calculated, this will be loaded, and accordingly you will be charged. So that yeah, there will be a change in price once you move out or move into the another service another pricing tier. Similarly, for the scaling out, where we will be increasing the number of instances. So there, the price shown over here for, let's say I am at the standard plan S1, which cost 1900 something, I think 2500 or 2895. It is the cost of per instance. So if you increase the number of instances, so similarly the cost will be multiplied. So let's say if you have 5 instances, then it would be multiplied by the 5. So that's how the pricing for the instance, once you scale up or scale out, so the pricing is calculated. I hope that answers the questions that one of the person asked.
Yeah, we have one more question asked by Ashish. So, how do we check application logs for troubleshooting? And are there multiple options available for this? So, yes, we have multiple options available for this. Let me just share my screen. So, in the app service, there are multiple options how to manage our logs. So, for example, we have this app service created. One straightforward integration which Azure App Service has is with Application Insight. We can turn on our Application Insight with the App Service, and once we enable this Application Insight, all our logs related to application, or be it by default request logging or exception logging, all these logs will be present in your Application Insight. So this is one of the way which you can use to push your application logs to Application Insight. So there's a very straightforward integration which Azure App Service has with Application Insights. So this is one way. Another way which we also have is which was demonstrated by Rami as well, is diagnostic settings. In this diagnostic settings, we get option, let this load. So we can add a diagnostic setting here, using which you can push your application logs to any of these destinations, be it log analytics or a storage account or an event hub. So you can select the HTTP logs, console logs, app logs, file audit logs. You can push all the metrics to any of these destinations. So once you create this diagnostic setting, your logs will be available to whatever target you select. But this setting is in preview. But this is very much in use. It is getting improved by Azure, but we can use this setting if we want for any of these kind of logs. Another thing which we also have here is app service logs. So in app service logs, we have multiple options, like we can put the application log to file system, blob. We can enable web service logging, server logging, retail error message, field request tracing. So let's say if I enable application logging from here, app service log once, and I save it, I can also see all the console logs and everything coming to my log stream as well. So this is saved, so I can go to this log stream and I can manage my logs from here as well. So this gives a very good way for you to see your live logs. You can see all the application logs coming here. If something is going on, maybe right now if I simply, not this one, if I simply do this, so all the live logs can be seen from here. Web server logs are system. So these settings can be managed from the app service log section. So these are the few ways using which, and then again we have this log section as well, which gives you default logs of like metrics and a few of the HTTP logs and exception logs. So these are the few ways using which you can manage your application logs. I hope this answers your question, Ashish.